All right, ladies and gentlemen, welcome back to derivative of inverse functions. This is going to be our last derivative rule. So if you recall back at the end of chapter 3b, right, we learned most of our derivative rules, right? We had finished up derivatives of logs and exponential functions, and I said back then we had one derivative rule left, and that is the one we're going to tackle today. So derivative of inverse functions rule, we'll get to that in a little bit. Let's do a little recap first. What's an inverse function again? It's been a while since we've talked about an inverse function, right? But we have the definition right here, right? It is a function that undoes the work of an original function. So if you have something like y equals f of x, right? Well, then the inverse function, right? Remember the -1 here next to the name of the function is not meaning reciprocal, right? Here it means the inverse of that function f, right? F inverse is going to flip the input and output of your functions, or another way of thinking about it is that it is going to flip the x and the y for your function, right? So if f of x equals y, meaning x is the input, y is the output, for the inverse function, we're going to flip those around. F inverse of y, meaning y is the input, is going to equal x. It is going to give us that as the output, okay? So let's review a little bit more with inverse functions here, right, by finding some inverses. So let's take a look at example 1 here. F of x is x cubed plus 6. Now, real quick, let's just get a value here. What would f of 1 be? So 1 cubed plus 6 would give us 7. And I have the wrong color. There we go. Would give us 7. Okay. So now, if f of 1 is 7, what that means is before I do anything with the inverse, I know that f inverse is going to flip around my input and output, meaning that f inverse of 7 is going to have to equal 1. Okay, so now let's go back here. Let's find the inverse function here. Okay, so again, inverse function is going to flip input and output, right? So that's exactly what we're going to do in order to find our inverse. So I'm going to flip all of my x's with y's and all of my y's with x's. So I'm going to treat f of x like a y here, and I'm going to replace it with x, and I'm going to treat my x here just like x, right? And I'm going to replace it with a y. So step 1, right, is to always flip x's and y's, okay? And now we're going to get the y by itself. So I'm going to subtract 6 on both sides. And now I'll take the cube root of both sides. So I get the cube root of x minus 6 equals y. And so, again, step 1, flip all x's with y's, flip all y's with x's, and then from there, do some algebra manipulation to get y by itself. And now, once I have that y by itself, whatever y equals is going to be my inverse function. So the inverse of f here is going to be the cube root of x minus 6. And if I double check that with what I know the inverse function is supposed to do, right, f inverse of 7 should equal 1. Well, if I plug 7 into this, right, 7 minus 6 is 1. Cube root of 1 gives me an output of 1. So that does indeed work, right, and it's giving me the inverse of my function f. Now, this by no means is the proof, right? Just because f inverse of 7 equals 1, you can think of infinitely many functions where you plug in 7, you would get an output of 1, right? The proof is the steps here in red of getting the inverse function, okay? So that's how you find an inverse function if you don't know it, but for some functions, you should already know what the inverse is. So for example, if g of x is e to the x, then g inverse should be another very common function. It should be the natural log of x, right? That's a common inverse as well. Okay, and then similarly, for h of x, right, which is x squared here in example 3, h inverse, right? So again, if I flip x and y, and then I were to solve for y, I would get plus or minus square root of x, and that would be the inverse of h, right? Right? But there's a problem here, right? What does a plus or minus in front of an x indicate? Well, it indicates that what we're looking at here is not actually a function. Okay, and so what that tells us is that h inverse of x does not exist. Okay, because we can find an inverse relationship, but that doesn't guarantee that it is going to be a function, right? You can't have two outputs for one input like plus or minus root x would give us. Okay, so not every function is going to have an inverse, and this is where we go back to things like we talked about in trig, right? The function we're looking at, h of x, has to be 1-to-1. It has to pass the horizontal line test. X squared does not do that. That is why h of x equals x squared does not have an inverse function. Okay, but we're not really here to worry about all of that today. This is all just some recap stuff. Okay, so let's talk about the derivative now of an inverse function, okay? And before we do that, right, let's start off with an important quality of inverse functions. So what would f of f inverse of x be? What do you get if you do a composition of inverse functions? And so here's a really quick example of that, okay? Add 2, subtract 2, right? If you add 2 and then subtract 2, those are inverse operations, right? They undo each other, right? So what happens when you do both of those? Well, you get back what you originally started with, which is just x. And that's going to be the same idea here, right? If you do at whatever f inverse does and then do whatever f does to the result of that, you are going to get back what you originally put in, which was just x to begin with. Okay? So this is something that is true for all compositions of inverses. Now, we could also flip this composition around. We could do f inverse of f of x as well, right? But there's a reason why I'm doing it this way, which will make sense in a moment, because here's what we're really here to do with this, right? We are going to take the derivative of this equation with respect to x, okay? Which means we have to take the derivative of each side. So we're going to take the derivative of the left-hand side, f of f inverse of x, and we're going to take the derivative of the right-hand side, which is just x. Okay, now I'm going to start with the right-hand side because this is the easy side. What's the derivative of x? It is going to be just 1. And now we come back to the trickier side here, left, and I said the magic phrase earlier, right? What we're taking the derivative of here is a composition of functions, right? So how do we take the derivative of the composition of functions? Well, we have to use the chain rule, right? So what does chain rule say? Chain rule says to take the derivative of the outer function here, right? And my outer function here is going to be just this f. So its derivative is going to be called f prime. And now chain rule says to keep whatever is inside of f inside of the derivative of f. So this is going to be f prime of f inverse of x times, and now I have to take the derivative of whatever is inside here, which is f inverse. Now, I don't know what the derivative of f inverse is, just like I don't know what the derivative of f was, right? So I just called it f prime. So here, I'm going to write f inverse, put a parentheses around it, prime of x. Okay, So again, what's the derivative of f? I call it f prime. What's the derivative of f inverse? I call it f inverse prime of x, okay? So this last parentheses x here is not multiplication, right? That's not what's going on here, right? This is supposed to be f inverse prime of x. F inverse prime is the name of the function, and x is the input for that function, okay? And this product, right, this chain rule here, is going to all equal 1. And now here's the thing, right? What we want to focus on today is what is the derivative of the inverse function? Well, that's just going to be this second part here of my chain rule. So the last thing I'm going to do is just to get that part by itself. I'm going to isolate that part. And so that is going to give me f inverse prime of x. And that is going to equal 1 divided by f prime of f inverse of x. So my orange function here, my f prime, right, that gets divided over to the right-hand side. And the thing that I want to isolate, the thing I want to solve for, is the derivative of my inverse function, which, again, I don't know exactly what the derivative is, so I just call it the derivative, the prime of f inverse of x, okay? And as weird as this looks, this is going to be our last derivative rule, okay? This is the derivative of an inverse function of f, okay? F inverse prime of x is 1 over f prime of f inverse of x. All right, so last derivative formula we're going to have to memorize here. Everything we did above here was just the short proof, right? This formula is what we're going to be using as a result of the proof, okay? So let's see this formula in action. Let's scroll down to example 4, okay? So example 4 gives us a couple of things, all right? It tells us that f of 2 is 5. And it tells us that f prime of x is 3x squared, okay? Now, there's something really important here in the given information so far, and that is that we don't actually know what f of x equals. Like, what is f of x? What is that function? Is it 2x plus 1? Is it x squared plus 1? Right? Is it 3x minus 1, right? What sort of function is it that has f of 2 to equal 5, but also, and this is where none of my answers were correct, right? It needs to have a derivative of 3x squared, okay? So this is going to be a problem, right? We don't know what f of x is. Now, the point of this sort of question is not to sit there and try to figure out what f of x is, right? Because if we knew what f of x was from the beginning, we could go back and do what we did up here, right? We could just find its inverse and then use our normal derivative rules and take the derivative, right? Like if I gave you the cube root of x minus 6, you could use chain rule and power rule and find the derivative of that, right? That's not the point of these sorts of questions, though, okay? The point of this question is we have enough to figure out what we are asked to find, which is what is the derivative of f inverse at x equals 5, okay? And so in order to do this, I'm going to follow along with my formula, right? So 1 over f prime of f inverse, and that x is going to be 5. So again, the derivative of f inverse at 5 is going to be 1 divided by f prime of f inverse of 5. And so here's the setup for my formula that we just proved up above. Okay, and now it's just a matter of evaluating, okay? And when I'm evaluating any sort of composition of functions, right, I want to start with the innermost part, which is what is f inverse of 5, right? What is f inverse of 5? Well, again, I don't know what f is, but we actually have all of the information we need. We know that f of 2 is 5, right? And what does an inverse function do? It is going to flip input with output. So I know that f inverse of 5 is going to give me 2, which means that I am doing 1 over f prime of 2. Okay, again, I don't need to know what f was in order to get that, right? I just needed that value, okay? And now my last step is going to be to take 2 and plug it into the derivative, which we are conveniently given to be 3x squared, and so I can do 1 over 3 times 2 squared, and now I can just evaluate that, and I get 1 over 12. Okay, so the point of these questions, again, is not to try to sit there and figure out what f of x is, right? I'm sure you could, if you sat there long enough, you could probably come up with something that satisfies both of the given conditions, right? But actually, using the formula here is pretty quick. Okay, if you remember how inverses worked, right? 1 over f prime of f inverse of 5. Well, f inverse of 5, right? You just take the given value here and flip it around. And so we're going to get 2, plug 2 into the derivative, and that's a pretty quick calculation to get 1/12. Okay? Okay, let's keep going. And let's take a look at our last example, which is 3 parts though, example 5. Okay, given the table and that g of x is f inverse of x, find the following. Okay, now there's 2 things in example 5 that are very common with derivative of inverse function questions. One is that very commonly you will see the inverse of some function given a new name. Okay, because ultimately what we're trying to do here is we're trying to figure out what is g prime of 1, right? And the first thing I like to do on these questions is I like to go, G, you're not really that helpful to me, okay? I want to focus on f inverse because my table has f values on it, right? And I have a formula for the derivative of the inverse of f. So the very first thing I'm going to do is I'm going to look at g prime of 1, and I'm just going to rewrite it back in terms of f. G is f inverse. What am I doing to g? I'm taking its derivative. So I'm also going to take the derivative of f inverse at x equals 1. Okay, so first thing that's very common with derivative of inverse questions is to have another name for the inverse function. Okay, so first thing I'm going to do is get rid of that. Now, the other thing that's very common with derivative of inverse function questions is kind of like the last one we looked at, is we don't know what f of x is, right? Like we don't have the function for that. We don't know if it's a quadratic, if it's an absolute value, a square root, whatever. And instead we get a table. So a table is very common in a derivative of inverse function question, okay? And so that's what we're going to work with today. Now, ultimately, what we have to do here is the same thing that we did above, right? I'm just going to go back and use my formula. What is the derivative of f inverse at x equals 1? So the formula goes 1 over f prime of f inverse at x equals 1. Okay. And now I have to look at that table and go, okay, f inverse of 1 is going to be what? And you're going to notice right away a very tricky thing is that on this table, there's an x value of 1, right? And then you can go f of 1 is 0. So a lot of people down here are going to misread this and put 0 right here, okay? But this is actually wrong. Remember, inverse function, right? Inverse function. So I don't want to look at this table up here and look at where x is equal to 1. I want to look at this f of x column because that's like my output column, right? I really should say row, sorry about that, right? F of x, I want to look at this output row. This is like my y values, right? I want to see where that is equal to 1. And now, what's my x value here? My x value here is -1, right? And so that becomes my output. So remember, inverse function flips input and output. So if 1 is the input here on the table, I'm looking to see where 1 is an output. And the input there, which was -1, is going to be the value here. Okay, so this is going to be 1 over f prime of -1. And now I can look back at my table and go, okay, when x is -1, what is the value of f prime? It is -1/5. So this becomes 1 over -1/5, and so we get -5. And that's my final answer. Okay, let's try this again. G prime of 0. So again, first thing I'm going to do, I don't like G. I'm going to get rid of it. So this is going to become F inverse prime of 0. Whoops. Okay, so now use my formula. So this is 1 over F prime of F inverse of 0. Okay, and a really common mistake people make with the formula is that they flip around the F prime and the F inverse. They go F inverse of F prime of 0, right? That's going to lead you down the wrong path. Okay, so what is F inverse of 0 going to be? So we look back at our table, right? We look here and, we're going to notice that, hey, 0 is not even an option in the x column, right? Which is good for us because we're not trying to look at the x column. I keep saying column when I should be saying row. Sorry about that. We want to look at the f of x row, and we see that f is 0 when x is 1. And so that's going to be my output here. It is going to be 1. And so I have f prime of 1 in my denominator, right? And now I can look back at the table and I can see that f prime of 1 is -1/6. So I have 1 over -1/6. So take the reciprocal of that and I get -6. Okay, and let's look at this one last time. G prime of 5. First thing I'm going to do is get rid of G. So we have F inverse prime at x equals 5. And so this is going to be 1 over F prime of F inverse. Whoops, that's a terrible 5. Let's get rid of that. There we go. Okay, so I use my formula, and now I'm trying to figure out, by looking back at my table, what would be the inverse of f at 5, right? I see it's in my f of x row, got it right this time, when x is -3, and so that's going to become my output here. And so I have 1 over f prime at -3. Okay, and so look back at my table. What is f prime of -3? It is -4, and so I get -1/4 as my final answer. Okay, so again, these sorts of questions very commonly, right, you are not going to get what the original function, f of x equals, right? And then the other thing that's very common, the inverse of that function f will sometimes be given another name. And so as always, I like to just get rid of that, right? I don't want to talk about g of x. All of my information is in terms of f, and so I'm going to rewrite everything in the name of the function that all the information is in. Okay? All right, so that's all we got for today. I will see you all next time.